President of Projects and Marketing at ADJ Engineering Private Limited. And he is a engineering professional who has almost 8 years of experience in railway diagnostics and monitoring system. So he has also played an instrumental role in timely supply and commissioning of first of its kind of a monitoring system, track monitoring system in Indian Railways, which is also known as integrated track monitoring system. So this track monitoring system was given to supplied to RDSO Lucknow, and it has very amazing features which provides video recording, analysis of image processing for the status of track components, identification of any obstacle in SOD of Indian Railways, full rail profile, wear measurement, and several other things. So I think Mr. Ravi Raj would give a more brief and detailed explanation of other features for this track monitoring system. So I think I will hand it over to Mr. Raviraj sir only, and all of you are requested to mute your mic and drop any of your queries that you have in the chat box. We will take up those questions at the end of this session, and we'll address each of those issues. So welcome Raviraj sir once again, and I hope yeah, I think yeah, slide is open only. Okay sir, go ahead. Sir, you are on mute.
Uh, Good
Uh,
afternoon, everyone. Ankur, can you see my slide?
yeah, yeah, we can see your slide. It would be better if you put it in full screen mode.
Yeah, sure.
Yeah, now great.
So, good afternoon, everyone. I'm Ravi, and I'm from ADJ Engineering Private Limited. We are a company based in Noida, and we are engaged in railways diagnostic, defense communication, radars, energy storage solution, and several other fields. For this particular project, which I'm going to appraise you all today, we have been partnered with a company from Russia, Messrs. Tivema, who is a world leader in railways diagnostic and monitoring segment. The company has more than 500 employees and 150 R&D engineers, which makes them capable of delivering a wide range of railways diagnostic and monitoring solutions. And their systems are working in more than 40 countries and in almost 5 continents. So let me just give you a brief about the project, which Indian Railways call Integrated Track Monitoring System. So this system is mainly focused to provide a comprehensive monitoring of the track infrastructure. I'll just give you a brief how it was being done before this system comes in IR. So railways used to do some PWI inspection, which PWIs goes on track, used to go on the track, and they used to take manual measurement. They used to see the defects by their own eyes and report it in their notebooks, and then they're taking other actions. Later on, railways introduced some contact-based track geometry measurement system, which were giving data about the track geometry, but the system was contact based and is a very primitive one. Later, they moved into contactless measurement system, which had track geometry system, half rail profile measurement, which is necessary to give you allow you to measure the track geometry also. It was not full specification system, and it was also having some acceleration measurement system. So railways decided to upgrade all the monitoring practice to enhance and take it to the next level as the whole world is now following. This is some of the images of our projects. So we have been operating this system since 2022 and have already completed more than 22 years of operation on Indian tracks. So the specification of RDSO which governs ITMS is mentioned over here. You can see that TMIM 382 is the specification floated by RDSO, based on which we developed, designed and manufactured this system and supplied to IR. It has 6 subsystems. The main one is track geometry measurement system. Second one is the full rail profile and wear measurement system. Third and the most important one is the system for video recording of track components and analysis, which allows you to identify the visual defects in the track in real time without any manual intervention. Then we have some acceleration measurement system on axle box, on coach pivot, and on locomotives. Another important system is system for identification of any obstacle in schedule of dimension of Indian Railways. And the last one is rear window video recording system. So in next slides, I'll be detailing about the functionality and the parameters which are being provided by all these six subsystems. So here you can see the general layout of the system. So we have been provided with a LHB coach, what RDSO calls track recording car, and on the same coach we have installed all our sensors. So on the leftist part you can see some sensors installed. These are the sensors which we utilize to identify any infringement in the schedule of dimension. Then here at the bottom, can you see my cursor?
Yes, we can see it.
Yep. Okay. So here we have our video inspection system, and then on the other side we have track geometry and rail profile measurement system installed, and we have several other cameras installed, which enables us to identify some special kind of visual defects. And then we have acceleration sensors installed on the axle box. GPS sensors are installed on the top, GPS antennas. In the lower bottom, you can see lower part, you can see the inside arrangement, how the working space are designed. So we have four operators consoles where we can keep monitoring the evaluations being done by the system, what are the defects and identified, if there is any urgent maintenance alarms. Then we have all the server racks, sitting area, and the printers are also there, which keeps printing during the recording time to give you a online report. So first system is track parameter recording system. So this system is based on inertial measurement principle, contactless. It has few main hardware what I'll point out. So we have inertial measurement unit, and we have a full rail profile system. So hardware for track geometry and rail profile system are same, and these as a combination give us the parameters of track geometry as well as the rail wear. So in the track geometry, we are able to measure gauge, cross level, alignments, twist, wear, cant, and gradient, which has been suggested by RDSO. The system here you can see there are two this kind of boxes, one for each rail. It has two laser lights, and then we have 3D cameras. So how it works? I use this slide. So laser points out or illuminate the surface of the rail, and then we use our 3D cameras to take the images. So we get some image like this, and then we interpolate and get the complete triangulated view of the rails. So these are the parameters which are being reported by track geometry system. Vertical profile on both rails, unevenness, lateral profile, alignments, gauge, twist, curvature, speeds, super elevation. These are the feature of track geometry system, and this complies with the latest norms of EN 138482, which is specifically tailored for track geometry systems. Then we have full rail profile. The hardware for, as I said, that hardware for track geometry and rail profile systems are the same. It complies with the EN standard of 13231 and 15302. So as I said that using the laser scanners, laser lights and the cameras, 3D cameras, we are able to measure the full profile of the rail. So this is here you can see the how we get the output. So the lighter blue part is the ideal rail profile, and then this black part and the purple parts, these are being captured by the system. And using the inertial measurement unit, we can identify the alignments of the rail, so which allows us to identify the proper alignment, how the rail is placed on the ground, and then we superimpose our measured image of the rail, and it then allows us to measure the wear parameters. Here I have detailed how the inertial measurement principle is working, the triangulation method, as I have already explained earlier. So the full rail profile system allows us to measure complete rail profile, vertical and lateral wear, horizontal wear, angular wear, rail inclination, lip flows, and this has also been commissioned in accordance with the RDSO specification and the EN norms. This is our UI screenshot, user interface screenshot, how the system reports when there is a wear. So here you can see the green part. It is the ideal rail profile, and this black and the purple part are the scanned images done by our system. So using the cameras, we can identify the shape, and the inertial measurement unit allows us to identify the alignments of the rail. We place it over on our software, and then we can identify the gauge measurement point using the weared out rail image, and we are it is possible that we can measure the rail gauge of the rails even if there is some wearing. So when railways was using some manual methods, manual practices for this measurement, due to similar limitation, it was not possible for them to get the proper uh, data of the track. So now after introduction of this state of the art technologies, it allows them to measure the wears properly, digital in a digital form, and kept for their records and for further maintenance. So now I am moving to the third and the most innovative subsystem of this ITMS. This is video recording system of track components. So here in this image you can see that we have used two line scan cameras for one rail. So in total there are 4 line scan cameras, and the sampling frequency of one line scan camera is almost 80,000 hertz. And here you can see we have some spatial lightning which enables that we can do the recording, and we can do the identify any defects in and without limitation on the lightning condition. So as I said that the sampling frequency of one camera is almost 80,000, which allows us to get the image of the track at a very high quality. I'll explain how the system works. So the line scan cameras capture the image of the track, and we get several pixels. Now our processor, it merges all this pixel and it creates it as a image, and when we keep interpolating, it appears that we are recording as a video, but in reality it is a single line image which is merged to form as an image and later as a video of the whole track. So why it is necessary to use such line scan camera of high sampling frequency? Because we are seeing very minute defects in the size of 0.1, 0.5 mm. Like there is some defects on the rail, like some linear defect or some gauge corner defect. So it is important that we have a very high quality images. so that we can differentiate the we can identify the defects of such small size. Now, when we have the image of the track, the video of the track, after merging all these pixels, we go to our system learning part. So first of all, we train our system that how the healthy track components look like. So suppose if we are training the system that how to identify a ERC clip, so we will feed all the healthy clips to our system. So once the system starts identifying the healthy clips, in the next step, we start teaching the system, making some models, how the defects look like. So using this principle, we create a mathematical model. It is not like that the system compares the images captured with the library of defects. It is not a image to image comparison. It is completely a mathematical modeling, and this mathematical modeling is tuned with time. It takes a long time for such visual system for a uh, new new railways, yeah, to train how to identify the healthy and how to identify the unhealthy components. So once we complete the markups, then we are able to generate a library of or mathematical model which is finally fitted on the system installed on TRC, and when it goes on track, it identifies the defects. So Indian Railways had specified us to identify more than 27 defects and components. Here on this slide, you can see what are the defects we are identifying. So the defects are mainly categorized in 4 parts. First is defects with rail, second defects with sleeper, and then with fastening, and last one is with ballast. So in rails, we are identifying linear defects, area defects, we are measuring joint gaps, and we are also identifying visual welds. Right. In the sleepers, we are identifying sleeper crack, sleeper misalignment, sleepers falling. We also check the sleeper level if there is something unusual with the levels of the sleepers due to missing fastenings. And in fastening, we are identifying missing clips, shifted rail pads, and missing bolts. In ballast, there are several defects associated with ballast, and RDSO is also specified to identify some components such as SEJ, axle counters, level crossings, and as I said, the defects of ballast such as excess or lack of ballast. It is possible that if our users wants to introduce some new defects, then we will again have to go through the system learning process and we can start identifying. So anything which is visually, which can be seen and which is visual, so that can be, the system can be trained and that can be identified. Here I have added some screenshots of our software that of the identified defects. So on this slide, you can see that we have identified a clip which is not inserted. So system identified both missing clips, and if a clip is not properly inserted, like it is already 50% out of its original place, then that system also identifies. So here on the screen you can see that as I selected missing clips, so we have all the defects. Almost 4,724 defects were identified in this section between Lucknow and Raebareli. On the next slide, you can see that we have measured the joint gaps. So system can measure the joint gaps more than 1 mm. And RDSO has specified that we should identify joint gaps which crosses 2 mm. So here in this image, you can see that a joint gap having more than a joint gap of 8 mm has been identified, and you can see several other joint gaps identified in this session. Next, you can see that system has identified missing bolts. So this all identification is being done in real time without any manual intervention. So we keep on recording and system keep on adding the defects in this list. Then we have identified sleeper misalignment. We also identify the distance between two sleepers. If there is a mud access, there is a access of or lack of ballast. So almost 27 defects we are identifying in real time. The next system, which is also very interesting, is system for identification of any infringement in SOD, Schedule of Dimension of Indian Railways. So Railways has specified us to identify any defects in a step of 100 mm, and to achieve that parameter, we installed almost 24 high-end LiDAR scanners. So LiDAR scanner are a type of laser scanner, but it keeps on revolving, and it has some mirror. So that allows us to create a 3D mapping of the infrastructure. In the next, I'll show you. So in the middle part, you see that how we get the 3D images of the infrastructure where we are doing a recording. It's a tunnel. So first of all, we get a 3D raw data in form of this. Then we interpolate it and we convert it to a 2D data. And there we introduce the different schedule of dimension envelopes, which has been specified by the user, in this case RDSO. So we are identifying almost identify defects in almost 7 envelopes now. So here you can see in the 3D image there is something, some object of the infrastructure which is coming within a envelope of tunnel which should not be there. So system identifies its size of infringement, the starting point, the end point, and we also have rear and front video recording cameras which can give you the image at this particular infringement location. So first we identified this red part in the middle image, you can see is identified by the system as an infringement. In the 2D you can also see that there is some infringement of the same place, and once we have this infringement reported, we also capture the image at that particular place and we report it to the users, so they can see that what exactly it is, what is the size of its this infringement, and based on that they take a decision how this should be addressed. This is a screenshot of recording done on bridges. So it is possible that we keep on adding several envelopes and system will identify any infringement in real time at a particular place with respect to all or one of these envelopes. Next system is a system for acceleration measurement. So as per RDSO specification, we have installed accelerometers at 3 locations. The first one is at Excel box, and the range of this accelerometer is 100 G, plus minus 100 G. This accelerometers installed on Excel box allows us to monitor the track quality. If there is any unusual with your rails, it will definitely reflect as a high value accelerations once we are recording. Next, we have sensors installed on coach pivot, which allows us to measure the riding comfort. So between the coach floor and the rail level, there are suspension. So we do not get as high data as we get on Excel boxes. So that is why we are using a 2G range of accelerometer on the coach pivot, and that allows us to measure the track riding comfort. And based on that, further actions are taken, because it is very important when we are operating a railways infrastructure. Passenger comfort is also a priority. So you must have all experience that sometimes we get a high jerks, and this is only because of some issues with the particular section, a particular point where it happened. It might be due to some unusual condition with rails or anything. So that needs to be addressed. And this system allows us to give us an insight of the conditions of track and passenger comfort using these accelerometers. So each sensor has two axes, so we can measure vertical and lateral accelerations at any of these accelerometers. So the last system is rear window recording system. It's cameras installed on the rear part of the coach, and we keep collecting the video images which can later be seen. So in case we get some any high peaks or any track defects, it is not necessary that the team should visit to see that what is exactly there. So after completion of the run, we hand over all these images, all these video recordings, so that when we are analyzing or we are seeing any uh, particular peaks or particular alerts, we can also see that what exactly this point is. So is there any track feature or anything is happening which is resulting into such peaks? Some track attention is being done. So this is the sixth subsystem and the final one. So the interesting thing about this project is that this system has been supplied by us, and the operation and maintenance of this system are also awarded to our company. So we will be doing the operation and maintenance for the next 7 years after commissioning of the system. So after every day's recording, we have some online reports. Then it is possible that we can compare the results of today's with any last recording which we did with the same system. So this allows us to see that if something improvement is there or the things has been deteriorated. And then we also have some special formats which allows us to upload the data on the track management system of Indian Railways. So here in the screen you can see some reports. So on the left side you can see that we have the reports of MMD SOD infringement identification system. So it shows you that which this particular report is about which special envelope. It shows you all the date, times, division, the size of the defect, the location, size of the defect, and its distance from rail center and height from rail level with some images. Then we have the graphs of all the track geometry parameters. So here we apply our thresholds and we get the track geometry alerts. Next is the track feature report. So on every track features, railways keep special attention to the track geometry. So this report is being used for monitoring of the track geometry at level crossings. This is user interface of track management system of railways. So after recording of the session, on each day we upload our results on the website of Indian Railways, and which later be accessed by any of the users in that particular section to take any necessary maintenance action. This So what are the advantage of such integrated system? It is when we do monitoring with different several numbers of vehicles. Suppose we use one system for track geometry measurement, we use another system for visual inspection thing, and for SOD. So when we integrate all this, we get a comprehensive data. In addition to that, that allows you to save the cost, ensure the reliability of your reporting when we cross compare the results of different subsystem at a particular place. The data, it is important that when railways is now planning to go for a very to enhance the speed limits, to enhance the axle load limits. A new set of trains with very advanced amenities are being introduced. It is same time very important that such integrated system are there, because the utmost priority is that the passengers and the travelers and the crew of the Indian Railways be safe during the operation. These systems are being used in other countries since last 1 or 2 decades, but lately it has been introduced in IR, and we believe that the introduction of these systems will open up new era of safety and more reliable Indian Railways network. So this is the end of my slide. I am open for your questions.
Uh, Thank you, sir. Thank you for that very insightful presentation and your explanation. We got to know a lot about how integrated track monitoring system works, what are its uses, and how exactly we are using that in maintenance and inspection of our Indian Railways. So thank you once again for that. We will take up all the questions right now. So if you guys have any questions, you can put it in the chat box or you can raise your hand and we can reach you one after another. Okay. So I think we have already have a couple of questions in the chat box. I'll go from the first one from Alvin. Uh, so Alvin says that interested to know the measurement accuracy, hit rate, percentage of the overall system, and roughly how long did it take, months or years to achieve this percentage accuracy. And another question is how is the geolocation accuracy of the defect detection assured?
So answering the question, answering to the first question regarding the accuracy rate. So as I said that the system conforms to some EN standard and also to the specification number which I mentioned. So for each parameters of track geometry, rail profile, and acceleration. There are some limits mentioned, the accuracy limits mentioned in these specification, and I can say that the system which is now working in IR is having the best accuracy which is available in world nowadays. If you want, I can show you the share the specification with you after this meeting, because every defect has a different limit based on its quantum. So I can share this data about the accuracy of this particular system. And regarding the geolocation accuracy, so in this system, we have three types of location synchronization facility. The first one is the basic one, and which we believe is the most effective one for IR, is a manual punching system. So once we start the recording, so on rail in Indian Railways track there are traction poles, and each traction poles corresponds to the particular kilometer chainage of the track. So we start recording and we have special punching system, so we feed starting point of our recording, and then we keep synchronizing, we keep punching at next coming traction poles, and system has some inbuilt algos which keeps on correcting the geographical location of the system. And I also like to add that as you have seen that the sensors are installed on several part of the coach, but the algorithm allows that when we are looking into the software, it shows you the defect. If we select a chain is say 5 kilometer, 5 kilometer and 5 meter, it will show you the particular location, the data at that particular location. So all this location difference, placement difference of the sensors is also synchronized in our system. Second second method of location synchronization is based on GPS location. So Indian Railways provide us route data tape, which has the location information, GPS location information of all its track features, and that can be uploaded before starting of any day's run, and that is utilized for the location synchronization purpose. And the third is Railways is also installing RFID tags, and that are placed on the center of the sleepers, and we have RFID antennas installed under frame. So using this tags, we keep on synchronizing and correcting the location at every 10 kilometers. So these
Thank you,
two
sir.
systems allows us to ensure that the location reported are accurate. And it's like if we talk about synchronization accuracy of GPS, it is almost 5 meters, but it depends on several other factors like how the satellites are available. But RFID is more accurate one that will also allow you to get the accuracy of 5 meters. So the accuracy is around 5 meters, 10 meters at a speed of 160 kilometer per hour.
Uh, Thank you, sir, for your response. Hope your questions are answered, Alvin. Sri Nagesh, sir, you had raised your hand. Do you have any query or any input?
Yes, yes, I do have a query. But first of all, Ravi, thank you very much. To see this. Being from the Indian Railway background, I have seen the HTR, the Halak Track Recorder, the OMS, the Oscillations Monitoring System, and the Amstar car. And what I see today is a game changer. I'm so happy to see all these things. Thank you very much for enlightening us. And the only question I have is I didn't understand the accelerometer versus track parameters. In how do you relate it?
See, it is not necessary when there is something unusual with track geometry. You will get a peak in terms of accelerations. So track geometry system gives you the actual measurement of a particular point of track, be it gauge, be it crossable alignments, but it is not necessary that these abnormalities will be reflecting as a acceleration. So acceleration is more important when we talk about the passenger comfort. So when there is a peak, this peak should be minimized. This vibration should be minimized. And these are sometimes due to unusual gauge or cross levels things. So in coordination of these two data, the passenger comfort can be improved. And acceleration sensors at the axle box, they give us more insights about the surface defects. If there is some unusual area defects on the rail surface, you get a peak, and that can be analyzed and checked later on.
In continuing to that, when you said passenger comfort, definitely the as laid cant will be not the actual cant for that speed. So there will be some cant efficiency. Is there any way of measuring any cant efficiency or rate of change of cant efficiency in your one of your methods?
Can can be measured, and all its deficiency can also be measured by the system.
Oh, great. Thank you.
Thank you. And we have next questions from Trideep Ghosh. So I think there are two, three questions. Trideep, if you are in the meeting, you can go ahead and ask the questions directly also if you want.
Yeah, it's fine.
Okay.
And I just want to curious to know that is there some like you said in the lidar, how wide it can take like the only for the envelope, or it can take the survey also, like
It
nearby infrastructure like bridges or something, so drains etc. So do it take that also?
Yes, yes. It's not about the survey of the envelope. It's wider one, almost 40 to 80 meter is the range. So we utilize that 40-meter range, and that can. So I think this range allows you to see the whole track, be it upline, downline, and nearby infrastructure.
Okay, and is it available? I guess this is for the existing geometry only for existing track. So for is there something for the like new kind for new greenfield projects also? Some kind of lidar used, I guess. For Indian Railways, I guess mostly like manual surveying is generally used with DGPS and all. Nowadays, drone is also using. So is there something for lidar?
Yes, so if you are talking about new track constructions, definitely this can be utilized uh, for this survey purpose. So you just need to have a track where you run the system, it collects the data, and then we using our software uh, we can identify any infringements to this. So it just need a reference point and proper scanning of the infrastructure along with this reference point, and then you can
Okay,
propose any envelope.
okay. It needs a path basically.
Yeah.
So in new track, like new project, sometimes we don't have the path. Okay, I get this. And this monitoring system, do they tell us about the geometry also? How much is the length? How much is the radius of particular length? Something like that.
Yes, yes. This in track geometry, we measure gauge, cross labels, alignments, unevenness, curvature, scant, I said. So all this can be measured.
Okay.
Okay, thank you, Trideep, for your questions. We have next question from Sankar Dev. Where was the mathematical model developed? Was it done in house?
See, this mathematical model, if I'm correct, it is regarding the visual system. So this is a mathematical model which is our own proprietary. So I just gave you a brief about how this works. I could not be able to go much detail about this particular software because this is something which is related with our proprietary and know-how. But as I said that this is not a image to image comparison. We developed, so I'll also explain few more lines about this. So suppose when I am training a system, I keep training and teach us with multiple numbers of images, and suppose uh, instruct my system that this is 100% healthy. So when I feed almost 100 image which is 100% healthy as per my understanding, system will generate a model of what is 100% uh, healthy thing, and then I keep training, like when the clip is not properly inserted, I keep on training that this is 90% healthy, this is 80% healthy, this is 70% healthy, this is completely unhealthy. So this can be compared, the mathematical model of unhealthy things is compared, and we instruct the system when you should raise an alarm or when you should identify something which is as defect. So suppose we fix the number at 70, so it will report something which is below 70, and this is how we adjust the false positive and false negative things in terms of visual defect detection system.
Uh, Thank you for your response. Hope, Sankar Dev, your question is answered. If not, you can ask anything directly if you want. I think, yeah, I think he has given a thanks. So we have next few questions from Liban. Liban, if you are on the call, still on the call, you can unmute yourself and ask those questions.
Yeah, thank you, Ankur, and thanks for the session as well. Very, I mean, basic questions, I would say. What is the speed of measurement that you can do with the machine that you have? And yeah, the second one was, looking at the arrangement of the camera, it felt as if turnout and crossover area, the machine may not be able to survey, but that I just wanted confirmation on that. The other thing is, since you are having auxiliary lighting, it seems you can undertake night measurements, but I would like to hear from you whether that's right. And what were the output formats that you are able to provide, be it to Indian Railways or to any other client? So yeah, those were my questions.
So answering first question, system is designed for 200 kilometer per hour, but as we do not have track of 200 kilometer per hour, we have already tested and commissioned this system at 160 kmph in Indian Railways. But yes, if the speed will be enhanced, our system is capable for that. So all the system has been tested at 160 kilometers per hour. Answering the second one, turnout and crossover. Yeah, there are some special parameters of geometry when we talk about turnouts and crossover. But all of those features cannot be measured because some of those features requires manual measurement uh, practice. So the main parameters, if we talk about gauge cross labels, system can identify on turnout, but the additional parameters which are only found at these places cannot be measured by this particular system. But we have several other systems which have these features, and I'd also like to inform that Railways is also planning to procure almost 15 or 16 similar system, but having capability of inspection of turnouts. Regarding third question, yes, we can do recording in any day and night condition. So when we go to Mumbai suburban section, it is not possible to run our system in the daytime. So there we do the night recording. Output formats, if we talk about, so it is completely based on user. So we have mainly three kinds of output. First is Excel or CSV based. So all the data are in or chainage wise or the sample wise are generated in Excel or CSV format. Then for some visual defects thing like the track component defect detection and SOD defect detection, we have some word based report format which has all this data along with image. Third format is database format. So when we are uploading our recording results on track management system of Indian Railways, so this we generate all the data in a special format and then it is uploaded on the website and which can be later accessed by the users of IR.
Uh,
Thanks for that.
thank you for your responses and questions. So we do not have any more questions. If you guys have any more questions, you can go ahead, and if not, I think we are good to close. Is there any more questions? I don't think so. So, thank you, Raviraj sir, once again for your insights and for answering all of our queries and questions that we had about the integrated track monitoring system. Uh, it was a great session, and we hope to get more of these insightful sessions with you again and again. So, thank you once again on behalf of PWI.
Thank you so much. Thank you, Ankur, and thank you to the entire PWI fraternity for allowing me to present how the railways is going to the next level and how we are helping them in that. I look forward to next sessions. Yeah.
Great.
Thank you again.
Thank
Uh,
you. Thank you.
Thank you.
Ravi. Thank
Mr.
you.
Mr. Raviraj.
Yes.
Yeah.
Uh, so thanks a lot for making it to this. We're really happy that PWI could be able to showcase one of the Indian Railways condition monitoring projects. We want to keep hearing from you about what developments ADJ is doing in this field in future also. So whenever you feel that you have some more value to add, please do reach us to our committee. We can give you another session.
Sure.
Thank you, sir. Actually, I am also planning to join the PWI membership team so that I be in the upcoming sessions. I keep hearing and asking and adding to these things.
That will be great.
I'm,
You're always welcome.
I'm dropping my contact details in the chat. So in case any of you have any additional queries, you can directly reach me out. I'll be more than happy to provide more information.
Thank you. Great session.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.
Thank you. Thank you,
Thank
everybody.
you all.
Thank you all.
Thank you all.
Thank you, Ash.
Thank you all.
Thanks
Thank
all.
you.
Yeah,
Thank you.
thank you, everyone.
Thank you, PWI team.